this is a great detective story. We're trying to learn what cancer did to somebody, right? So we need clues to lead us through that story of what actually happened. That's where the biospecimens come in. People can actually help give us the clues which are attached to pieces of their body or their tumor or their blood.
Biomarker and biospecimen research are the way to move forward. Technology is growing exponentially, and we're at the era in my field, which is cancer care, where technology is starting to impact us on a daily basis.
As the technologies become more sensitive and more specific, you are able to detect changes in cells and tissues at a deeper level. The biospecimen is, in truth, the center of the universe of molecular medicine. It's where all the molecules are. So it represents the biology of the patient and the biology of their disease.
Because we're learning more and more about the genetic basis of disease and the genetic basis of treatment response, we need better qualified specimens in order to make those kinds of improvements.
These technologies are so good to be able to look at millions of data points that if there are a couple of errors, whether they be on the annotation and how you describe the specimen, or whether they be on how the specimen was handled, they get amplified and they can lead people astray. It's better to have little data than it is to have data that's incorrect. And so what we start to need is to be uniform in how we collect things, uniform in how we attach data to it.
You could waste a lot of time if you're using tissue which has been inappropriately handled and not stored properly, because you could come up with a biomarker that might just reflect that storage process. Even if it's just blood that's collected into a tube, it's now in a completely different environment. It's responding to that environment that isn't as oxygenated as it was in your body. There are gene expression changes. All sorts of things are changing.
The specimen is a living entity, and it is perfectly biologically capable of reacting to these stresses, which are extreme. The changes in temperature, the changes in blood flow, the exposure to multiple types of drugs. These stresses have the capacity to completely alter the molecular makeup of the specimen in ways that we don't understand.
I became aware of the problem because I was in charge of a department of pathology where I wanted tests not to be variable. When I looked at the quality of the tests we were providing, I found out that there was wide variation in the test results.
Think about the drug target or drug discovery process. If the sample collection has been variable, it could certainly lead you down a wrong path. We need good quality samples so that we can understand the expression of our drug targets to identify whether or not the drug is working in the manner that we expect it to.
As a patient who wants to donate their tissue or their biospecimen, we're trying to help science learn as much as possible about cancer so that they can do something about it.
I'm a cancer doc in the trenches, so one of my focuses clearly is I want these technologies and the results from the biospecimens available tomorrow. I had 2 patients already today that have passed away from cancer. So I'm not in a position of waiting. I'm not in a position of planning for the next decade or 2. It's tremendously important, but I care about things today, and I want answers that I can use in the near term.
The way we're doing things just is inadequate. Maybe even worse than inadequate. It may be giving us the wrong answers more efficiently and effectively as you apply bigger technologies to them that are leading us down pathways that are too expensive in terms of manpower, money, and loss of time in progress for cancer patients.
There's some way to influence how samples are collected in a more routine manner so that standard operating procedures can be employed. That means that there'll be a much greater array of samples that will be useful to the entire research community.
If we are optimizing specimen handling for research and we create a new drug or a new therapy for patients based on that research, then the standard operating procedures that we used for that success in the research will then become the standard of care for every patient in real-time clinical medicine when that benefit is applied throughout the medical community.
When you give something like a biospecimen, you aren't necessarily going to get anything out of it, but the answers that science can learn from that can help the next group of people that are going to be treated or that are going to avoid cancer. And that may be your own family members, it may be your other friends. And it may mean that they don't have to go through as much as you had to go through as a patient.